Okay, guys, so now we're going to talk today about physical versus chemical changes. This can kind of be difficult to distinguish between physical and chemical changes, especially if you don't really know what's going on, right? There are indications of physical chemical change that we'll talk about, but even those are a little shaky sometimes. So it is quite a difficult subject, but basically a physical change is something that can be most of the time reversed. They can be reversed, whereas a chemical change cannot really be reversed too easily. But again, that's kind of also a little bit tricky too, because if you do a reverse reaction, if you go backwards, you can do a reverse chemical reaction. But anyway, all I'm getting at is that this is a tricky topic. If you get some of these things wrong, it's okay. So let's look first at this part here. It says identify a type of changes in each of these examples. So let's see if we can figure it out right off the bat here without even learning anything just yet. So sugar dissolves in warm water. That's going to be a physical change. Sugar does not break down when it goes into water. It just separates. It moves and it dissociates into the water. Okay, a nail rusts. That is a chemical change, and that's chemical change because of color change. Glass breaks, a physical change. Anytime you hear breaks or tear or something like that, it's going to be a physical change. A piece of paper burns. Anything burning is going to be a chemical change. Iron sulfur mix and form partially magnetic black and yellow mixture. Okay, this one's a little bit tricky. So iron and sulfur mix and form a partially magnetic black and yellow mixture. I'm not sure. Is it reacting? We'll see. I'm going to say that since it's still magnetic, that the iron is still iron, so it's going to be a physical change. I'm going to say we're mixing it, but let's see. Iron and sulfur are heated and form a non-magnetic shiny gray substance. Ooh, so now it's not magnetic anymore, so the iron changed its physical property. So I'm going to go with a chemical change there. Dry ice, solid carbon dioxide, is sublimed at room temperature. Sublimation is a phase change. Most phase changes are going to be a physical change. Okay, vinegar reacts. Anytime you hear reacts, that's automatically a chemical change. Water boils, so that's another phase change, so physical. And zinc, when immersed in hydrochloric acid, produces hydrogen gas. So anytime you see a gas, that's going to be a chemical change. Let's see how I did. I got them all correct. Oh my goodness. It doesn't even say, it doesn't even go all the way down 10, but I know I got them all correct. So, yeah. All right, let's move on. So that was kind of a little pre-test there. If you're doing a tutorial on your own, hopefully you did that one and you got. It's okay if you didn't get them quite right. It's all right. Okay, so let's talk about. I'm going to skip through this. Let's look at physical versus chemical properties. So physical properties. Let's look here. Physical properties are things like boiling point, melting point, freezing point. Also, whether they conduct electricity, whether they're magnetic, whether they're malleable, so meaning that they can be like molded into something. So things that don't change, there's no chemical reaction involved here. Physical properties do not involve chemical reactions. Things like color, texture, external appearance, those are all also physical properties. Okay, pretty simple. What else here? Anything else here? So melting point, boiling point, good conductors, yep. Malleability, all that good stuff. Ductility. Okay, let's talk about chemical properties. So chemical properties are a little bit more difficult to understand because chemical properties are basically how do they react? How do they react? Well, one of iron's chemical properties is that it rusts. When iron is around water and air, it will turn into iron oxide. It will also react with acids and sometimes react with bases. So those are all chemical properties. pH, so pH is a chemical property. pH determines what things it will react with. So acids typically react with bases. Okay, so if something's acidic, it's going to react with a base. Okay, Reaction with oxygen. Will it react with oxygen? So rust is an example of reacting with oxygen. So rusting, burning, or combustion. So if you hear the word combustion, that means burning. That means reacting with oxygen in the air to form carbon dioxide and water. Okay? So here we go, look, reaction with water. So something like, oh yeah, this is a really cool example here. We have sodium or potassium. So this is potassium in water. When it reacts with water, it actually catches on fire. What's actually happening here is the potassium, when it hits water, it reacts, it gives off hydrogen gas and heat. So much heat that that hydrogen gas actually catches on fire. So that's actually what's happening. That's actually what's happening there. So does something react with water? That's another chemical property. Okay. Reactions with acids and bases, again, is a determination of a chemical property. Okay. So let's look. Let's try again here. We're going to do another little quiz here. Glass breaking, that is a physical change. Submit answer. Hammering wood together to build a playhouse, physical change. Rusting a bicycle, that would be a chemical change. Melting butter for popcorn is a physical change. Separating sand from gravel is a physical change. Spoiling food is actually a chemical change. Mixing lemonade powder into water, physical change. Okay, we're not actually changing the lemonade, we're just mixing it in water. Mowing the lawn is a physical change. Corroding metal is a chemical change. Bleaching your hair is a chemical change, it's changing color. Fireworks exploding, chemical change. Squeezing oranges to make oranges, physical change. Frying an egg, chemical change. Anytime you cook something, it's usually a chemical change if it's changing, like cooking an egg, cooking fish, whatever. Pouring milk in your oatmeal is a physical change. Burning leaves, chemical. Baking salt water to gargle with. This was a tricky one. I could argue either one of these, but I think they're going to say physical change. However, we could argue that's chemical. But it's if you really understand what physical and chemical means, you could argue that salt, things breaking into ions, is kind of a chemical change. But anyway, whipping whipped cream, physical change. Burning toast, chemical change. Freezing chocolate, physical change. Melting ice cream, physical. And what? I got one wrong? Which one did I get wrong here? Oh, I must have hit the wrong button by accident there. Whoops! That was definitely physical change. I don't know why. I guess I hit the wrong button. Anyway, let's go to the next thing. Okay, physical property. Vinegar has a pH of 2. That is a chemical property. Bromine boils. Boiling is physical. Baking soda is a white crystalline. That's a physical. Sodium catches fire. That's a chemical. Corn syrup has a density. Physical. Iron rusts. Chemical. Come on, get in there. Yeah, I got them all right. Okay, next thing. Physical versus chemical changes. So we're going to look at the difference between physical and chemical changes now. Okay, just give it a second here. Oh. So let's watch this video real quick.
Finding pure metal in the ground is rare. Most metals are combined with other elements in the Earth's crust to form rocks.
This is malachite and it contains the element copper, and this is pure copper metal. For thousands of years people have known how to extract this metal from the rock.
Malachite, otherwise known as copper ore, is found in the ground. This mine here at the Great Hall in Llandudno dates back to the Bronze Age, a time when copper was used for making tools and weapons.
But first you need to find some malachite.
Underground there are over 6 kilometres of narrow tunnels.
Where I'm walking now was originally a vein of green pristine malachite. It was dug out by people over 4,000 years ago, leaving behind a maze of passages and chambers. So just imagine this whole cavern was once filled with copper ore.
First miners used large stones to dig out pieces of the precious green rock. Malachite isn't just one element, it's made of several. As well as copper, it contains carbon, oxygen and hydrogen.
To extract the copper from the rock, you need to get rid of all the other elements, and that's done by a process known as smelting.
First, the malachite is crushed, then it's placed in a crucible ready for heating. In the Bronze Age, copper ore was smelted in a small furnace made of clay. It reaches temperatures as high as 1,000 degrees Celsius. Of course, they didn't know that in the Bronze Age, they just knew it had to be very hot. Air pumped in through bellows helps the furnace reach the right temperature. Then, in goes the crucible and it's covered with charcoal. The charcoal reacts with all the other elements in the malachite, leaving behind the copper. And the result, liquid copper, an element. Once the copper has been extracted, it can be poured into a stone mould. It quickly solidifies and begins to take on the shape of an axe head. Its beauty and durability make copper a highly prized element. Today, copper ore is mined on a huge scale and smelted in massive furnaces. Copper metal is used for all sorts of everyday items, like water pipes, coins, and copper wire. Tin is another metal element which can be extracted from rock. This is a lump of tin ore. As well as tin, it contains oxygen. Smelted, and once again, So what's the difference between one element and another? Copper and tin are made up of particles called atoms. In pure copper, all the atoms are the same as each other. It's the same with tin, but tin atoms are bigger. A pure element is made of just one type of atom.
I think it's pretty cool to see how they extract certain elements from different rocks and stuff. That's pretty cool. Yeah. So, okay, chemical changes. So that was all actually chemical changes. The copper wasn't changing. Was combined with. I should say was changing. It was combined with oxygen, hydrogen. So was the tin, and then it was being burned to a point that the oxygen and hydrogen would leave in the gaseous phase, and it would turn into pure copper and pure tin. There's a couple of things that happen when a chemical change occurs. We can have a transfer of energy, a change in color, and we have a new observable product. So sometimes you'll see gas bubbling out or precipitate forming. So really there's 4 indications right here: transfer of energy, change in color, new observable product, gases bubbling, or precipitate forming. I should say 5. There's really 5 things here. Okay, so we're going to be looking for those different things when we talk about a chemical change. Okay, physical changes are typically reversible. Like I said, typically reversible. For example, you take ice and it freezes, turns into water. Then you take it out, it can melt, turn into water, and then you put it back in the freezer, it can freeze again. So they're easily reversible. Okay, and in both those cases, it's still H2O. All right. Okay, so a physical change can also occur when you're dissolving something. And again, that whole salt thing is a little bit tricky, but that is technically a physical change, I guess. Okay, so let's watch a little clip about physical and chemical changes here. While I'm waiting for that to load, we'll move on to the next thing here. Okay, So hard water contains calcium and magnesium, which undergo oxidation and clog water pipes. Which statement best describes this change as a chemical change? Calcium, magnesium dissolve in water, and that would be a physical change. Calcium, magnesium evaporate. Evaporation is a physical change as well. Calcium and magnesium form precipitates. So anytime you hear that word precipitates, that's going to indicate a chemical change. Okay. Let's see, is this video ready yet? Okay, let's watch this video. Kind of boring. We're just looking at different, is there a chemical reaction occurring or not, I guess. This is boring. And we're not going to watch this one. Boring. Alright, let's look at this. Leaves turn yellow in autumn. It's changing color, so we're going to go with chemical change. Coals burning to ash. Burning is a chemical change. Lighting an electric bulb. This one's tricky because it is giving off heat and light, but you're putting energy into it. You're putting energy into it. When you put energy into something and it's changing temperature or giving off light, that doesn't necessarily mean it's a chemical change. If you don't put energy into it and it gives off heat or light, then it is a chemical change. But this one we're putting energy in, so it is a physical change. Silver turning black. Changing color is almost always a chemical change. Sugar dissolves in water, physical change. Burning a sugar cube. Anytime you hear burning, chemical change. Distilling salt water. So we're separating water and salt. That's physical change. And wax solidifying, physical change. Okay, done. Got them all right. Good job, me. I'm the best. Okay, summary here. So physical versus chemical change, physical properties, chemical properties, all that good stuff. It's kind of all a review here. Remember that chemical change has to have one of those 5 indicators, a color change, a change in visible product, a creation of precipitate or bubbles, heat, or it could get even cold. There's also an instance where you mix 2 things together and they can get cold. So temperature change without adding any energy would be considered a chemical change. Okay, things like physical changes would be like heating, boiling, freezing, change in phase change. Okay, yeah. So again, right here, that gives you all that kind of right there. So again, this kind of, there's like 3 right here, but there's actually 5. So we have transfer of energy, change in color, new observable product. So this is 1, typically a gas or precipitate. Okay. Okay, and then you take the quiz. We could take the quiz again. If you want to try this quiz again, you can do it again. Okay, and that is it for this one. I'll see y'all next time.